Good afternoon, sir.
Good afternoon, Gaurav.
Yes, sir.
So, Gaurav, just tell me for which subject and just give your brief intro about yourself and for which
Sir,
company you want to give a snap.
yes, sir. Sir, am I audible, sir?
Yeah, you are audible.
Yes, sir. My name is Gaurav Tiwari. I completed my B.Tech from Motilal Nehru National Institute of Technology in Mechanical Engineering, and I'm here for the snap of strength of materials for DRDO scientist B post.
So, Gaurav, just tell me what are the basic assumptions under the bending equation.
Sir, bending equations. So first of all, we assume that the material is homogeneous and isotropic. Then we assume the condition of pure bending. Having no shear force, axial load, or twisting moment. Only constant bending moment is acting on the material, and then we also assume that the cross section is uniform throughout the beam we are taking. And so that's it.
Can you just tell me what is the difference between the simple bending and a pure bending?
Yes, sir. Sir, simple bending is a type of bending which has both shear force as well as bending moment. On the other hand, pure bending is a type of bending in which there is only bending moment is present and no shear force, axial load, or any other type of loading is present. And one more thing, simple bending, we have the parabolic type of bending curve, and then in pure bending, there is a circular bending. The arc of the bend, sir, is circular.
The pure bending.
Yes, sir, pure bending. If, of course, if the flexural rigidity of the component is constant throughout, so it will be in circular bending, in pure bending case.
What do you mean by flexural rigidity?
Sir, flexural rigidity of a beam is the product of Young's modulus of elasticity and area moment of inertia about the neutral axis. Sir, it basically tells about the resistance that a beam offers to the applied bending load.
Okay.
Yes, sir.
What do you mean by resilience?
Yes, sir. Resilience is defined as the energy absorbed by a member up to the elastic limit. That is the area of the load deflection curve up to any point within the elastic limit is called resilience. So it basically tells how a component will perform when it is loaded below the yield point. Yes, sir.
Okay. So I'm just asking another question.
Yes.
If I'm just talk about the stress strain curve. So first of all, just define them as different points in that. What are they?
Sir, starting with first we have a slope of the stress strain curve in slope of the initial region that gives me the Young's modulus of elasticity. Then we have the proportional limit till which the stress induced in a body is proportional to the longitudinal strain. Then we have elastic limit up to which if we remove the load, the component comes back to its original position. Then we have yield point, upper yield point, and lower yield point. And then we have ultimate stress, and then we have fracture stress.
Just differentiate between the yield point. What is the meaning of a yield point? Why this is observe upper yield point and lower yield point? And how it will be formed?
Yes, sir. A yield point basically marks the onset of large amount of plastic deformations without the significant increment in the load. Sir, this scene of upper yield point and lower yield point is because of the interaction of edge and screw dislocations with the existing point defects like vacancies and impurities, and this formation of upper and lower yield point is on the basis of Frank source mechanism, which says that whenever dislocation encounters a point defect, the point defect tries to resist the motion of the deformation, which causes the increment in the load. And as the load increases, it suddenly drops to a lower value because now that edge dislocation is split into two parts, and it will start moving very freely in the component. So the stress suddenly reduces to lower value because of this reason. So the upper yield point and lower yield point.
Who will teach you the material science? Abhishek sir?
Abhishek sir, no sir. I studied at MedEasy.
Okay, which teacher?
Sir, Shastri sir, I remember.
Okay, Shastri sir will taught you, right?
Yes.
You are also doing the coaching from the MedEasy. In which year?
Last year.
And you were passed out in which year?
2019, sir.
Right. So there is so many good faculty in the NITIE. So why you need to take a coaching?
Sir, actually passed out to repair. In the MNIT, yes sir. MNIT, of course, Abhishek sir taught a batch other than MNIT, but since material science is a subject that is taught to us in the, I think, third semester, and sir, all the mechanical engineers are yet to get themselves introduced to various concepts which we use in material science later. Very difficult for a third
network problem हो रहा है काफी ज़्यादा गौरव शायद कोई नेटवर्क
सर एक सेकंड सर मैं
वीडियो म्यूट कर दो
सर अभी आवाज आया क्या सर हेलो
हाँ आ रहा है
हाँ हेलो अभी आवाज आया सर
yes
हाँ सर तो what happens sir for a third semester student it becomes very difficult to understand such a conceptual material science subject in the third semester, but later on as we study other subjects like the production and also we could get a greater concept of material science. And also I didn't study. Ajay Bharti sir ने भी नहीं पढ़ा सर हमें KM Gupta sir ने पढ़ाया था सर material science.
KM Gupta sir ने पढ़ाया है.
हाँ Paul sir ने Paul sir ने flute mechanics पढ़ाया था सर. I am also a product of a MNIT Ahmedabad. So I know which year? 15. Sir, which year? Okay, I got admitted. 15. This I one of your batchmate I might know. Vineet Tripathi, you know? Don't remember. Maybe. Okay, we will discuss about it later. Okay. Yes, sir. Yes, sir. So can you just tell me in this material MS diagram there is a cup and cone fracture also? Can you just tell me why it is only the cup and cone? Yes, sir. In ductile material. Yes, sir. In the ductile material, it's not every time we get a cup cone fracture. Only when we load a material in a uniaxial, uniaxial loading. So in the uniaxial tensile loading, since we use a ductile, since mild steel is a ductile material, so it is weakest in shear. So it tends to fracture from the points where the shear stress is maximum. And when we analyze the uniaxial state of stress, we come to know that the shear stress is maximum at 45 and 135 degree plane. So we get a cross. Wait a second, sir. We get a cross like this. So we get a cross like this, and then the material starts fracturing from here and here. So we get separate these 2 points, and then we get a cup and cone type fracture. Okay, can you just tell me why, if I'm just taking the compressive load in that condition, so what will happen in the MS diagram? Yes. This testing curve. Yes, sir. How yes, the curve look like, and what's the difference between them? Right? Yes, sir. Nowadays, you are working in somewhere else? I worked, sir, for almost 2.5 years, and then I resigned for a preparation. Sir, this is like this is how it will be, sir. For a compression. Yes, sir. For a compression, initial region, the initial linear region will remain same for both in tension and compression because the Young's modulus remains same. But as the material deforms, the stress continuously increases in the compression state diagram, because the material is not getting weakened, rather it is getting stronger and stronger as the area is increasing. So after a certain time, after a certain point of time, we need a very large load to deform the material in compression, and finally the component either fails in buckling or will fail in crushing.
Okay, how the fracture will occur? At what angle?
Yes, sir, that's what. At what
angle also?
Achha, in that case, sir, fracture. It may be possible that fracture occurs. Then it will occur in case of buckling, because the compressive stress will be more than the buckling stress. So it will buckle along the about the area which has the least area moment of inertia, or if it is crushed, so it will be crushed from everywhere. There will not be any point where the crack will initiate, because what is happening is in tensile test, because of reduction of area, the component was weakening, so we can get a clear cut fracture point. But here what is happening, since area is continuously increasing, so we generally don't get a particular fracture point, so it will crushed throughout, sir.
Good, Gaurav. Today we have a lack of time, so I'm just giving only the 15 minutes for that. Surely we will meet you in the next step, and we will just discuss some questions also. And whenever you will just want to,
Yes,
if you are not available at the time, and just take some time from me, directly message me. I will just give you some other time also.
Sir,
yeah.
On the same number, sir.
Yeah.
877.
Yeah. This is my person.
Okay, sir. Fine. Yes, actually, sir, I had one more thing also, sir. I want you, because, sir, my college project as well as my work experience is both related to this strength of material and machine design. So, sir, I want you to take a snap of that also, because I think that will be the major part in DRDO interview.
What's your project name? Just tell me.
Yes, sir. The project, not right now, sir, actually. Not right now, just whenever you get a time. So I just wanted to inform you that if it's possible, please schedule for that.
Sure. Your interview will be on 11th of April. Before that, we will do that.
Yes, sir. Yes, sir. At least once or twice we can discuss about this project and work exna. So it will be good experience.
Before that, in which company you are just working?
Sir, Bajaj Auto.
Good. So okay, we will just discuss it shortly.
Okay, sir. Fine. Thank you, sir. Sir, any feedback regarding this?
Today you are good. There is no doubt that your knowledge is also good, and I am sure that you will be selected. There is no such issue. But we will just discuss something depth things or some questions also.
Okay, sir. Fine. I'll contact you, sir, whenever I.
Today I'm just taking some basic question, and your answer is really good. Impressive answers. There is no.
Okay, sir. Fine. Thank you, sir. Thank you so much. Okay.